Well, hello, Algebra 1 students. Welcome to the 7th lesson of Topic 1. This is the 7th and final lesson of Topic 1, covering absolute value equations and inequalities. So absolute value is a special term in math. I don't know if you've been exposed to it yet, so if it's your first time, very happy to teach you. But when you think of absolute value, think of distance from zero. Distance from zero. And we'll talk about that further distance from zero. And then when you think of distance, right, you should think of a positive number. Okay, so those two things, distance from zero and being positive. Keep that in mind as we go through today's lesson. Okay, so it says, what is the value of x in 7 equals the absolute value of x plus 2? Okay, so the first thing we're going to do is get this absolute value of x by itself. So you see these bars, right? So again, this is pronounced absolute value of x. That's how you say that. So we're going to get this by itself, right? So right now, the plus 2 is over here with the absolute value of x. So let's subtract 2 on both sides. And we get 5 equals the absolute value of x. So I'm going to rewrite this with the x first. So the absolute value of x equals 5. And again, this question is asking, give me the x's whose distance from 0 is 5. That's what this question is saying. What are the values of x that the distance from 0 would be 5? So if you look here, right, here is a number line, here is 0, right? If we go 5 to the right, we're going to land at the number 5. And if we go 5 to the left, we're going to land at the number -5. These are the two solutions, 5 and -5. So x could be -5 and x could be 5. And that's it. That's the answer. Now we could also write it like this, x equals plus or minus 5, if you have that opportunity. It's however you want to do it. But this is what absolute value means. Distance from 0. And notice that the absolute value, the value of x can be negative, but when you put it inside the absolute value, it turns it to positive, right? So the absolute value is always a positive number. Okay, next. All right, so it says, what is the value of x in absolute value of 2x minus 3 equals 1? So right now, okay, we have the absolute value isolated. There's nothing outside of it, nothing added or subtracted. Everything is inside. So what we're going to do is we're going to split this. We're going to split this into two equations. So the first equation, we're going to write 2x minus 3 equals 1. Okay. The second equation we're going to write is 2x minus 3 equals -1. And the idea is the following, right? If you took the absolute value, if the 2x minus 3 equaled 1, the absolute value of 1 is still 1. If the 2x minus 3 equaled -1, the absolute value of -1 would still be 1, which is what the right side equals. So what's inside the absolute value could be a positive 1 or a -1, and this solution would be, or this equation would be true. So now we have to find the two values of x that make that happen. All right, so let's solve this equation first. X is being multiplied by 2 and subtracted by 3. So let's add 3 to both sides. 2x equals 4. Let's divide by 2. X is 2. So there's one of the solutions. The other one here, same idea. Let's add 3 to both sides. 2x equals, but now because it's a -1, -1 plus 3 is just 2. Let's divide by 2, and x is 1. So your solutions are x equals 2 and x equals 1. Done. So those two values of x, if you plug them back in, will give you a 1 inside this absolute value and a -1 inside the absolute value, both of which, if you take their absolute value, equals 1. Okie doke. Next. All right, what is the value of x in 3 times the absolute value of x plus 6 plus 8 equals 5? So now we need to isolate this. So what is happening to the absolute value of x plus 6? It's being multiplied by 3. It's being added to 8. So we have to get rid of the 8 first by subtracting. So 3 times the absolute value of x plus 6 equals negative 3. Then we need to divide by the 3 to get rid of the 3. Absolute value of x plus 6 equals negative 1. And now we have a problem, right? I just got done telling you that absolute value is the distance from 0, and absolute value always has to equal a positive number. This is a problem because negative 1 is a negative number. Your absolute value, an absolute value, cannot equal a negative number. So there is no value of x that I could plug in here, and the answer would come out to be negative 1. So this has no solution. And there you go. So 2 things from this example. Notice the isolation of the absolute value. Ask yourselves what's happening outside the absolute value. Undo that. And then number 2, watch out for this trick. Make sure they don't have the absolute value set equal to a negative number. That cannot be true. All right, next. Okay, it says apply an absolute value equation. The cruising speed of Kennedy's boat is 25 miles per hour. She plans to cruise at this speed for the distances shown in the diagram. Part A, what equation models the number of hours x that Kennedy will travel? All right, so if you see this here, right, this plus, this minus 10 miles, plus 10 miles, right, this is what you're going to be taking the absolute value of, the negative 10 and the positive 10, and you're going to get 10 both times. So keep that in mind, right? So I drew down here. So we're looking for something in the absolute value that's going to equal 10 because it could come out to be negative 10 or positive 10. So what is going to go inside this absolute value? Well, this right here is the distance, right? We need to write an equation that models the number of hours x that Kennedy traveled. Number of hours. So first off, we're going to do distance equals rate times time, or rate times time equals distance, whatever. Let me do rate times time equals distance to stay consistent. We want to solve this for time, right? Or we're going to replace x for time. So our rate here is 25 miles per hour. So this is your rate. The distance, we know we have to go 80, right? There's this 80, but then you have this plus and minus 10 miles either way. All right. So what we're going to do is in the absolute value, we're going to put our 25 and our x for time. We're going to put a minus 80 inside there because again, this plus or minus 10, it has to be added to the 80. So you'll notice that if you can think ahead, when we create the equations and solve, we're going to have to add the 80 to both sides. Or add the 80 to both the 10s and the negative 10. So this is going to equal 10. There's your absolute value equation. Okay. Now again, it's a little bizarro. I get it. But just to kind of recap, inside here, so 25 times x, right? That's a distance. So 25 times x is a rate times time. You're subtracting the 80, which is the distance between, and that's going to equal the 10 that you go less than or greater than, depending on which way you're cruising. Okay, and again, I think it's this idea of you have an upstream versus a downstream. Because if you're going at a constant speed, right, upstream, downstream, you're going to gain some distance with the current. Okay, so now I think part B is going to make a little more sense. So now let's go on to part B. So part B says the cruising speed at Kennedy's boat is 25 miles per hour. She plans to cruise at this speed for 80 miles plus or minus 10 miles. What are the minimum number and maximum number of hours that Kennedy will travel? So this is where we're going to take that equation from part A, which was the absolute value of 25x minus 80 equals 10. And we're going to split it up. 25x minus 80 equals 10. 25x minus 80 equals negative 10. And we're going to solve this, right? And we're going to find this x, which is time, and we're going to see the time between her travel, like how long, how short she might have to travel. So let's add 80 to both sides. 25x equals 90. Let's divide by 25 on both sides. X equals, and this comes out to be 3.6, and it'd be hours. Over here, let's add 80 to both sides. 25x equals 70. Let's divide by 25 on both sides. X equals, and we get to 2.8. So here are the hours traveled. And again, one is, downstream, one is upstream, that kind of thing. So our minimum amount would be 2.8 hours, and our maximum amount would be 3.6 hours. And there you go. Okay, all right, so this is the video 1. We'll stop. Video 2, we'll get into more inequalities.